Good morning, doctor. My name is Hugh Hong Jeng. Today, I'm going to present about ways to measure, monitor, and evaluate the water quality. The water quality will be influenced by different physical, chemical, and biological factors. Environmentalists using some water quality monitoring system to identify water pollutant by natural and human being. The result of the monitoring system can be used to plan the maintenance project of water source. First is the CDOM or FDOM monitoring. CDOM is color or chromophoric dissolved organic matter. It can absorb ultraviolet light and decompose to release tannin. It causes water turn murky, reducing the pH of the water and depleting the oxygen levels. CDOM can be measured by using these electrical optical sensors. It will detect the light availability in water bodies. Second is the chlorophyll fluorescence analysis. Algae flourish when the surface of water rich in minerals. This will lead to oxygen depletion and increased level of nitrogen and phosphorus, which can be toxic to the flora and fauna. This can be measured by using algae toximeter. It will indicate the percentage of wet chemical chlorophyll and also active chlorophyll. Third, conductivity, salinity, and TDS monitoring. Conductivity will affect the salinity and total dissolved solids content. It will also affect the concentration of oxygen in the water. Ecological and man-made pollution factor can increase or decrease the water body's conductivity. This monitoring can be done by conductivity, salinity, and TDS meters. By measuring the specific electrical conductance of electrolyte dissolved in the water. Next, recording the water temperature. Temperature affects the rate of photosynthesis and metabolism, the dissolved gas concentration, the conductivity and salinity, the pH, and the water density. Ammonia at a high pH is toxic to plant and aquatic animals. However, a sudden change in temperature can double the impact. This monitoring method can be done by using thermometers, thermistor, thermocouples, and digital temperature sensors as shown in the diagram. Fifth is measuring the dissolved oxygen levels. This is a measure of the amount of oxygen available to the flora and fauna. Oxygen levels decrease due to the decomposition of organic material. Normally, the DO level in the water less than 6 mg per liter can be harmful. This measuring can be done by using electrochemical or optical sensor, calorimetric method, Winkler titration method, optical dissolved oxygen sensors as the diagram shows in here. 6. pH and KH testing. A safe pH range for a pond or lake is between 6 to 8. The pH of the water alter and increase the level of toxic ammonia. Electronic pH sensor, which is valued up to 2 decimal point, can be used in this testing. KH, or the carbonate hardness, is a measure of carbonate and bicarbonate levels. It significantly impacts the value of pH of the water. Lastly, assessing the turbidity, TSS, and clarity. Low or high level of ultraviolet radiation can halt the photosynthesis process. Suspended solid cause the water cloudy and impacting the penetration of sunlight into the water. Sudden increase of TSS is an indicator of soil erosion and point source pollution, adding heavy metals and effluents into the water. Nephelometer is used to measure the scatter light. TSS can be measured by filtering and weighing the sample and are measured in milligrams of solid per liter of water. In conclusion, these 7 methods will help humans to evaluate the various parameters that determine the water quality in freshwater and brackish water bodies. By measuring and monitoring the key indicators of the quality of water, researchers and environmentalists can plan and execute strategies to conserve the water bodies and encourage biodiversity. So that's all from me, and thank you.